you're welcome to Master T Math class. And in this live class, we want to look at application of matrices. Stay tuned and watch to the end to gain maximally from this class. And also don't forget to give us your thumbs up and share this video as well. Now, the first application we are looking at is solutions of simultaneous equation. Solutions of simultaneous equations using determinant method. Using determinant method, and they call this Cramer's rule. So that's another name for the determinant method. It is called Cramer's rule. Now, let's look at the general way of solving this. Given the equation, now we look at two equations in two unknown first. That is when we have two equations with two unknowns. Two equations, two unknowns. Then here it will be in this format. This we have a11 x plus a12 y equals to c1, and the second line we have a21 x plus a22y equals to c2. Here c1 and c2 are constants, and we have a11, a12, a21, a22 are also constant from here. Then this method here, the first thing we do is to find the determinant, denoted as delta. Determinant here is, we find the determinant of the coefficient here, that is this constant here, which is determinant of a 2 by 2 matrix a11, a12, a21, a22. Now that is the determinant. Then the next thing is to find determinant with respect to x. We call this delta x here. And for this, we are going to replace the first column standing for the variable x. The first column standing for the variable x, we replace that with a constant here, as if we have c1, c2 now. Then we maintain this as a12 and a22. Then we find this, that's the determinant with respect to x. Then the same way we find determinant with respect to y. That is, the column of y here, we replace it with a constant, which implies that the determinant with respect to y will then be a11, a21. Then this second column will replace with a constant here, which is c1, c2. Then, therefore, x will now be determinant with respect to x over the determinant. That's how to get x now. And also y is same thing as determinant with respect to y over the determinant. This is the general format to solve simultaneous equation using the determinant method, also known as the Cramer's rule, for two equations in two unknown. Now let's demonstrate this with examples. Now use determinant method to solve the following simultaneous equation. Use determinant method. Example from here. Use determinant method to solve the following equations. We have the first one, x plus 5y equals to 3 equals to minus 3 from here. Then we have 2x minus y equals to 5. This is the first one. Then the second one, which is number 2 now, we have 2x plus 3y equals to minus 2. And also the second equation, we have 3x plus 4y equals to minus 6. Now, since we are using determinant method here, solution from what we have, the first one here, which is x plus 5y equals to minus 3, and the second equation, 2x minus y equals to 5. Now, first thing is to find the determinant. And the determinant here, we write out the coefficient of these variables. That is, here we have 1 as the coefficient here, then we have 5 here. Then the second line, we have 2, then minus 1. Then the determinant here will become, we multiply the major diagonal, 1 times minus 1, that's minus 1, then minus 5 times 2, that's minus 10. 5 times 2, that's 10. Then we have the determinant here, minus 1 minus 10, that's minus 11. So that's the determinant. Then the next thing, find the determinant with respect to x. And here, we just remove the first column, which is the column for x. Then replace that with the constant here. That is the variable on the right hand side. That is here, we now have minus 3, 5, then 5 minus 1. And when we solve this here, minus 3 times minus 1, that's plus 3, then minus 5 times 5, that's 25, which implies we have minus 22 from here. So determinant with respect to x, minus 22. Now, find determinant with respect to y. And here we change the column for y. The column for y, this is the second column. We replace that with the variable on the right hand side. That is, here we have 1, 2. Then here we now have minus 3 and 5. Then when we solve this here, 1 times 5, that's 5. Then minus 3 times 2, that's minus 6. That is, here 5 minus minus 6, that's 5 plus 6, which is 11. Now, we can now conclude here that therefore we have x will then be equals to determinant with respect to x over the determinant. And determinant with respect to x, we have it as minus 22 over the determinant, which is minus 11. And here, this gives us 2 from here. Minus cancel minus, 22 over 11, that's 2. And also here, determinant with respect to y is is 11. So therefore, y here will now be equals to determinant with respect to y over determinant, which is 11 over minus 11, which is equals to minus 1. So therefore, here we have x equals to 2 and y equals to minus 1. So here we have the solution to the first equation using our determinant method from here. Then when we run a check here, you can substitute the value of x and y into any of these equations to see if we are correct. Now, for x equals to 2 and y equals to minus 1, then here we are going to have 2 plus 5 times minus 1 will it be equals to minus 3? Of course, this becomes 2 minus 5, because plus times minus is minus. So we have 2 minus 5, and 2 minus 5 is minus 3, which is equals to minus 3 here. So that means the solution, which is x equals to 2 and y equals to minus 1, satisfies these equations. Now, let's look at the second question as well, using the Cramer's rule. That is, from number 2 question here, we have 2x plus 3y equals to minus 2. Then we have 3x plus 4y equals to minus 6. Then we can find the determinant first. Determinant here is determinant of 2, 3, then 3, 4. And here this becomes 2 times 4, that's 8, minus 3 times 3, that's 9. 8 minus 9, that gives us minus 1. So the determinant here is minus 1. Now, determinant with respect to x now, here we replace the first column, which is column for x, with the constant on the right hand side. That is, here we are going to have minus 2 minus 6. Then this remains the same as 3, 4. And here, when we multiply out, minus 2 times 4, that's minus 8. Then minus 3 times minus 6 here, that's minus 18. We should not make a mistake here. There is a minus before, in between. And when you multiply 3 times minus 6, that gives us minus 18. And this becomes minus 8. Minus minus here is plus, that's plus 18. Which implies here we have minus 8 plus 18, that's 10. So determinant with respect to x here is 10. Now, we can get delta y as well, determinant with respect to y. We maintain the first column as 2, 3. Then the second column for y, we interchange it with the constant on the right hand side, which is minus 2 minus 6. And this becomes, here, 2 times minus 6, we have minus 12, then minus, here we have minus 2 times 3, that's minus 6, which implies we have minus 12 plus 6 now, and which is minus 6. Now, to get x and y now, easy, since we have delta x as this and delta as this, so x is now equals to delta x over delta, which implies we have, let's use it, okay, so that leaf is still showing there. So here we can conclude that x is not same thing as delta x over the delta, and delta x here is 10 over the determinant minus 1, and x here is minus 10 now from what we have. Then also we have y to be equals to delta y over delta and delta y minus 6 over minus 1, and this is 6. So therefore we have x equals to minus 10 and y equals to 6. Now we can check and put this in one of the equations here. When x equals to minus 10, what we have becomes 2 times minus 10 here, then plus 3 times y, 3 times 6, with the result be minus 2 from here. And when we look at this, 2 times minus 10, that's minus 20, minus 20 here, then plus 3 times 6 here, that's 18, is equals to minus 2, of course. Minus 20 plus 18, that's minus 2. So therefore, we conclude that here x equals to minus 10 and y equals to 6. Now, let's look at some interesting other question from here. Let me write out some for us to try out. So we can use determinant method to try this question on our own. So using determinant method, we can solve the following equations simultaneously. X minus y equals to 1 as the first equation, and we have 2x plus 3y equals to 12 as the second equation. Then number 2, we can solve this as well. 2x plus 3y equals to minus 5, and also we have x minus 4y equals to 14. So let's try these two problems using the Cramer's rule, which is determinant method. Now, this is for two equations in two unknown. Now, very quickly in this class, let's look at three equations in three unknown. So for three equations in three unknowns, the general way of handling that similar to two equations in two unknown. Now, let's quickly check out from here three equations with three unknown and here this generally when we have a11x plus a12y plus a13z equals to c1, and we have a21x plus a22y plus a23z equals to c2, and also we have a31x plus a32y plus a33z equals to c3. Now here we are going to find the first thing, which is determinant. Write out the coefficient on the left hand side. That is, here we have the coefficient here as a11, a12, a13, a21, a22, a23. And also here we have a31, a32, a33. Here we have a 3 by 3 matrix. So we find the determinant denoted as theta from here. Then next thing is to find determinant with respect to x. Now here it means the first column, which is standing for x, is going to be replaced with a constant on the right hand side. So replace everything here on this column, and this column will be c1, c2, c3 now. Then we maintain this other one as a12, a22, a32, then here a13, a23, a33. So this is determinant with respect to x. Then x will then be det x over determinant. So this is how to get x. Once we get the det x and we get the determinant, x is det x over det. Now, the same thing for y. For det y, we are going to replace the column of y here. That is a constant here, which is the second column. We replace it with a constant on the right hand side. Then we maintain the other ones. That is, here we have a11, a21, a31. The second column replaced now becomes c1, c2, c3, and we still maintain the third column, which is a13, a23, a33. Then we evaluate this determinant, and therefore y will now be equals to determinant with respect to y over determinant. So that is the value of y. In the same way for delta z, here we maintain the first two columns, and the third column, which is the column for z, will be replaced with the constant on the right hand side. That is, here we have A11, A21, A31, then we have A12, A22, A32, then the third column replaced with C1, C2, C3. We evaluate this determinant and this determinant with respect to Z. So therefore, Z here will now be equals to determinant with respect to Z over determinant. So this is general way of handling, three equations with three unknown using Cramer's rule, determinant method. So very quickly, we can demonstrate here with some examples. Please help us to share this class, and thank you by giving your thumbs up and also subscribing to us. Now let's look at some examples to demonstrate this. Solve the following simultaneous equation using the determinant method. So, which is three equations and three unknown. The first one from here, we have x plus 3y minus 2z equals to 1. And also we have x minus 2y plus 2z equals to 3. Then the third equation, we have 2x plus 3y then minus 4z equals to minus 4. So this is the first question from here. Let's solve this first before we look at the second one. Now, solution here. The first thing, we find the determinant by writing out the coefficients of the left-hand side. That is, we have a 3 by 3 matrix here. So the coefficient of x here is 1, of x here is 3, of y here is 3 rather, of z here is minus 2. Then here we have 1 as well. We have minus 2. We have 2. Here we have 2. We have 3 minus 4. Now let's find determinants here. Now, here you need to be careful with the signs so as not to make a mistake. We have, look at finding determinant of a 3 by 3 matrix in our previous lab class. You can check as well to understand it better. Now, we can expand through the first row here, and the first row has the sign of plus, minus, plus. Don't forget. So determinant here will now be 1 times here. To make it faster, we don't need to waste our time. Once you take the element here, cancel the column and cancel the row. So you are left with this 2 by 2 matrix here. Just find the determinant of that. And how do we find that? Minus 2 times minus 4, that gives us plus 8, then minus 2 times 3 here, that's 6. So that's all. Then we have minus in the middle, that's minus 3 now. Then times. Also cancel the row and the column. So 3 here is in the first row and the second column. Cancel it out. First row, second column, cancel out. So you are left with 1, 2, 2 minus 4 here, which is a 2 by 2 matrix. Now, when you find determinant there, that's 1 times minus 4, that's minus 4, then minus 2 times 2, that's 4. So here you have that. Then also, this is plus. But here we have minus 2, so it's same thing as minus 2. Then times what we have here now, cancel the row here, which is minus 2 here is in the first row. Then the third column, cancel the first row and third column out. Then you are left with this 2 by 2 matrix here. This 2 by 2 matrix, which is 1 minus 2, 2, 3. Find the determinant. 1 times 3, that's 3. Then minus 2 times 2, that's minus 4. You should be careful. We have 2 minus there now. The minus is already, connecting the major and the minor diagonal, but we still have minus here. Minus 2 times 2, that's minus 4 now. When we now simplify, determinant here becomes 1 times 8 minus 6, that's 2. Then minus 3 times, minus 4 minus 4 minus 8, then minus 2 times 3 minus minus 4, 3 plus 4, that's 7. Then here you have determinant now equals to 1 times 2, that's 2, minus times minus become plus, 3 times 8, we have 24, right? Then we have minus 14 here. 24 minus 14, 10. 10 plus 2, that's 12. Determinant here equals to 12. Now that we have determinant, next thing is to find determinant with respect to x, okay? Now, determinant with respect to x here will be equals to, just, you are still using the same thing here, but you are going to change something there. You are going to change the first column, which is standing as x, the column for x. Then you replace it with the constant on the right hand side. So here, the constant on the right hand side, here we have 1, 3 minus 4. Then you can write the other two columns, which is 3 minus 2, 3, then minus 2, 2 minus 4. Then here, find out the determinant here. So very fast, expanding along the first row, you take 1, then multiply by, when you cancel the row and the column, 1 here is in the first row and first column. Cancel the first row, first column. You are left with this 2 by 2 matrix. So you have the determinant of this 2 by 2 matrix will be minus 2 times minus 4, which is plus 8. Then minus 2 times 3, that's 6. Then here, minus is in the middle here, we have minus 3, then into brackets. Also the row of 3 here, which is row 1, then column of 3 here, column 2, cancel it out. Cancel row 1 and column 2. Then you are left with this 2 by 2 matrix. And find the determinant here. We have 3 times minus 4, minus 12. Then minus 2 times minus 4, minus 8. Then we have plus minus 2, which is minus 2, into brackets. Also cancel the first row, which is minus 2 here is in row 1, then column 3. Cancel the first row, then the third column. We are left with this 2 by 2 matrix. Then the determinant there is 3 times 3, which is 9, then minus. Minus 2 times minus 4, which is 8. Now you can simplify, and from here, this is 1 times 8 minus 6, that's 2. Then minus 3 times minus 12 minus minus 8, that's minus 12 plus 8. And that gives us minus 4, right? Then here we have minus 2 times 9 minus 8, that's 1, which implies here we have 1 times 2, that's 2. Then minus times minus, that's plus. 3 times 4, that's 12. Then here we have minus 2. 2 minus 2 cancel out. So here we have 12. So determinant with respect to x is 12 now. So let's write something here. We got determinant, because I want to rub this off. We get determinant to be 12. We get determinant with respect to x to be 12 as well. Now, let's get determinant with respect to y now. So, very quickly from here, determinant with respect to y will be similar to what we have here as the determinant, but we are going to change the second column. The second column, which is a column of y, we change everything here to the constant on the right hand side, which means here we still have the first column, the same thing, 1, 1, 2. Then the second column replaced as 1, 3, minus 4. And the third column maintained as minus 2, 2, minus 4. Then we evaluate this determinant, which implies here, this expanding along the first row here, we have 1 times, cancel the row of this element, 1 and the column. We are left with this 2 by 2 matrix. Find its determinant, 3 times minus 4, that gives us minus 12, then minus 2 times minus 4, that's minus 8. You should be careful of the sign here. We have 2 minus there. Then close bracket. Then at the middle here, there is a minus. Then minus 1 times, cancel the row of this element 1 and its column. That's row 1, column 2 cancelled out. So you are left with this 2 by 2 matrix. When you find the determinant, that's 1 times minus 4, then minus 2 times 2, that's 4. So I believe we are getting it and finding it interesting. Thank you for watching now. Here also, we have plus here, but there is a minus 2 here, so it will be minus 2, then into bracket. Cancel the row and the column of this element. So we are left with this 2 by 2 matrix, which implies the determinant here, 1 times minus 4, that's minus 4. Then minus 3 times 2, that's 6. Now, we evaluate this from here, and we have 1 times minus 12 minus 8. Same thing as minus 12 plus 8, and which is minus 4, right? Then we have minus 1 here times minus 4 minus 4, that's minus 8 here. Then minus 2 times minus 4 minus 6, we have minus 10. Then which implies 1 times minus 4 is minus 4. This minus times minus is plus. 1 times 8, that's 8. Then also minus times minus is plus. 2 times 10, that's 20. And when you look at this, minus 4 plus 8 is, of course, 4 plus 20. And this gives us 24. So determinant with respect to y, let's keep it here as well. And that's 24. Then you find the determinant with respect to z as well. That is, the next is determinant with respect to z. Delta z also will be equals to, all we need to do is to change the column of z here. That is the last column here. And we replace that with the constant on the right hand side. That is, here we still have 1, 1, 2. Here we have 3, minus 2, 3. Then here now we change this as 1, 3, minus 4. Then find the determinant here. Expanding along the first row, we have 1 times. We cancel the elements on the row and the column here. We are left with this 2 by 2 matrix. And you find its determinant. And you have minus 2 times minus 4, that's 8. Then minus 3 times 3 here, that gives us 9. Then here we have minus in the middle, that's minus 3 times. Also cancel the row and the column here. Excuse me. You are left with this 2 by 2 matrix as well. Then 1 times minus 4, then minus 3 times 2. Here we have 6, then plus 1, then times, cancel the row and the third column. First row, third column cancelled out. We are left with this 2 by 2 matrix. And we have 1 times 3, that's 3, minus 2 times 2, that's minus 4. Then when we evaluate this here, this implies we have 1 times 8 minus 9 is minus 1. Then minus 3 times minus 4 minus 6, that's minus 10. Then plus 1 times 3 minus 4, that's 3 plus 4, which is 7. And here we have 1 times minus 1. Then minus times minus here plus 3 times 10, 30. Then plus 1 times 7, 7. And here we have minus 1 plus 30 plus 7. Here we have 36. So determinant with respect to z here is 36. Now, easily now we can conclude and say, therefore, here, okay, very quickly, we said, therefore, here, x will be equals to delta x over delta, which is 12, over 12, which is 1. So x is 1, and y equals to delta y over delta, which is 24 over 12, which is 2. And here we say z equals to delta z over delta, which is 36 over 12, which is 3. So here we have x equals to 1, y equals to 2, and z equals to 3. Thank you for watching so far. Thank you, and don't forget to subscribe for more videos. We meet again in our next live class. See you and bye for now.